Hello students, how are you all? Welcome back to Akshar IIT Foundation classes. I am your chemistry faculty S. Mohan. Students, under the IIT Foundation chemistry for you grade 7, we are already started a topic called atomic structure. And in that atomic structure, we are completed up to 3 synopses. Today, we are going to discuss about the 4th synopsis, right? So, before going to the 4th synopsis, let us once briefly see the 3rd synopsis, what you have learned. In the 3rd synopsis, students, I explained you about the cathode rays. I explained about what? Cathode rays, right? So, how the cathode rays were discovered. Who discovered the cathode rays? J.J. Thomson, right? So, in the previous class, we discussed about the J.J. Thomson's discharge tube experiment. In that, J.J. Thomson discovered the cathode rays, and cathode rays are nothing but electrons. These are the negatively charged particles, and these particles are traveling from cathode to anode. So, that's why they are called as a cathode rays, and they produce a shadow. Okay, they travel in a straight line, and they can produce a mechanical energy. So that shows that they are not a rays, but these are the stream of a tiny particles called electrons, and they are attracted towards the means they are deflected by the electric field and magnetic field. They are deflected by the electric and magnetic fields. And we also discussed about the charge to mass ratio of electron and the charge of electron also. And the charge of electron, how much it was? Minus 1.602 into 10 to the power of minus 19 coulombs, right? So, this is we discussed in the previous class about the cathode rays and electrons, their characteristics, properties we had discussed, and their EMI ratio and the charge of electron and mass of electron we discussed in the last class, right? Now, today we are going to discuss about the synopsis 4, that is discovery of protons. Electrons we discussed in the last class. Now, protons, they are also called anode rays and their characteristics, right? So, now see students here, last class we discussed the discharge tube. Did you remember the discharge tube? Right. So, discharge tube is what? A glass tube, okay, and approximately like this. So, here also we use the discharge tube only in the discovery of protons or anode rays, and here it consists of one cathode and one anode, okay. So, this we connect to the positive terminal and this we connect to the negative terminal, okay. So, here it is a battery or source of electrical energy, this is a key like this, right. So, here this is a positive terminal and here it is a negative terminal, right. So, here there is a positive terminal, so this is called anode. What it is called? Anode. So, we write this as a anode, right, and this is connected to negative terminal, right, and this is called what? Cathode, right. So, this was the arrangement. In the discharge tube also similarly like this only, the discharge tube was there in the discovery of electrons, that is the cathode rays. So, here students, observe carefully here, logically you think what I am going to explain you logically, just you think. See, generally atoms are neutral. Neutral means what? Neither positive nor negative charges, they are neutral, right. And in the last class we discussed that J. Thomson discovered the electrons. Electrons are what? Negatively charged particle. So, how these particles have come? From the matter which is present taken in the discharge tube, from that electrons have come. So, electrons are negatively charged particles. If atom is neutral, for example, if this is neutral, and from this neutral means what? No, neither positive nor negative. From this, electrons are coming out. Electrons are what? Negatively charged particles. Negatively charged particles are coming out. So here, if it consists of only electrons, then this should be of negative charge. This body is of negative charge, but it is neutral. The meaning of neutral means what? The equivalent amount to the negative charge, some positive charge should be here. Yes or no? So to neutral means what? 0. Okay. So here if the electrons are present, means negatively charged particles, then to be a 0, to be a neutral, here there should be equal amount of positive charge also should be there, right? So Goldstein thought and observed that if atom is neutral and from the atom electrons are coming out, electrons means not negatively charged particles are coming out, then there should be a positive charge in an atom. There should be a positive charge in an atom, right? So how this positive charge is present? So for that same experiment, discharge tube experiment only, he conducted, and during this time what he done is, this is the anode, means positively charged electrode, right? This is cathode, means negatively charged electrode, right? Now in this negatively charged cathode plate which is there, he made holes to the cathode plate. What he made? He made holes to the cathode rays. Sorry, this cathode plate which is there, to this cathode plate he made some holes. So it's called a perforated cathode plate or perforated cathode. Okay, he made some small holes to this plate, right? And he arranged a screen behind this. Okay, so arranged one screen behind this, okay, which is called a fluorescence screen, which is called what? Fluorescence screen. And whenever the charged particle strikes, to this fluorescence screen, this forms a sparks called scintillations. Okay, it forms one sparks, right? So this was the arrangement. Now conditions are same. What are the conditions I said? The pressure is maintained 0.01 mm. What are the conditions in the cathode rays? Same conditions here also maintained. The condition is what? The pressure is maintained 0.01 mm. Okay, and voltage is how much? 10 kilovolts, means what? 10,000. Kilo means what? 1000. So 10,000 volts potential difference is maintained. Under that conditions, what happened? The cathode rays are produced. How? What I said. So whatever the gas molecules are there inside, that splits, from that cathode rays are coming out. Okay. So now what happened? The cathode rays. Okay. So cathode rays here I represent with the blue color. So now what happens? The cathode rays are releasing from the cathode. So this is a cathode. Okay. Releasing from the cathode, and these are moving towards the anode. How they are moving? They are moving towards the anode. Like this. They are moving towards the anode. Clear? Now, if atom is electrically neutral, from that if the electrons are going away, so this possesses a positive charge. Okay. Now positively charged ion is left. Yes or no? So these positively charged ions, which are left, they are attracted towards the cathode. Why? Because cathode is negatively charged. Cathode is what? It is connected to the negative terminal of the battery. And these, when the electrons are removed from the gas molecules, what are the ions formed inside? Those ions, electrons are removed, so they are positively charged, right? You know that like charges repel, unlike charges attracts. So now whatever the positively charged particles, whatever the positively charged ions, we can say particles, or we can say particles. Okay, I am denoting with red color. Now those started traveling towards the cathode. Towards the cathode. As the cathode is perforated, perforated means what? Holes are there. So now what happens? They passed through the holes. They passed through the holes. Okay, like this, and they strike to the at the cathode. Where they are striking? At the cathode. At the cathode, they are forming the scintillations, means what? Sparks. Okay. So from this, what I came to know, here these are the positively charged particles. What are they? Positively charged particles. Okay, yes or no? So neutral atoms are neutral. From that, electrons are going away. So when the electrons are going away, then it becomes a negatively charged, positively charged. So then this positive charge will be moving towards the cathode. Okay, negative charge, because unlike charges attracts, right? So now these particles which are moving towards the cathode, okay, cathode is what? Negatively charged. So which are moving towards the cathode, negatively charged. So and from where they are coming? They are coming from the anode. So that's what they were named as. This red color name, okay, particles are named as anode rays. What they are named as? Anode rays. Okay, and these are only later found to be positively charged particle called protons. Clear, students? So that is the discovery of protons. Any doubt in this one? Okay, once again briefly I will explain you. So in the last class we discussed that J.J. Thomson discovered the electrons. Electrons are nothing but a cathode rays. Cathode rays are nothing but a negatively charged particles. So these negatively charged particles are releasing from where? From the atom. Okay, so but atom is neutral. When the atom is neutral, the meaning is what? The amount of positive as well as negative charges are equal. Now from that, electrons are coming out. When the electrons are coming out, then what happens? This remaining part of the atom should consist of a positive charge. Yes, so that positive charge, okay, that consists of a positive. This was observed by the Goldstein. Remember the name? Goldstein. So Goldstein discovered the protons. Okay, so then what he observed is, so when the cathode rays, on the last class what we discussed, the cathode rays means what? Electrons are releasing, means they are moving towards the anode, means what? Positively charged. Similarly, the positively charged particles which are produced inside, that positively charged particles are moving towards the cathode. How the negatively charged particles or electrons moving towards the anode? Similarly, positively charged particles are moving towards the cathode. So these particles were named as anode rays. Later, they were also called as protons. Clear? Any doubt till here? No? Understood? No? Chalo, right. Now let's see the characteristics of the cathode rays. Characteristics of cathode rays are exactly similar to the electrons. But small change. So they are exactly similar to the electrons because electrons are the particles, anode is also particles. Electrons are the charge carriers, means they carry negative charge, and here they carry the positive charge. That's the difference. Okay, and remaining properties remain same. So what are the characteristics we discussed? Characteristics. Okay, characteristics of the anode rays. So characteristics of the anode rays, what it is? The first one is that the anode rays also travel in a straight line. How they travel? In a straight. They travel in a straight line. So when they are produced from here and they are moving in a straight line, that's the first thing. So this also same property like electrons. Electrons also move in a straight line when there is no other charges or there is no electric and magnetic fields, then it will move in a straight line. So they are also moving in a straight line. And second one, okay, they also produce mechanical energy. What is the mechanical energy? They created the motion in the wheel. In the cathode rays we discussed, if we place one wheel in the path of the cathode rays, then what happens? That wheel rotates. So here also, these anode rays also rotating the wheel. So that's what these are how the produces the mechanical energy. And third one is what cathode rays are deflected in the magnetic field. Sorry, in the electric field. Here also, these also deflected. Deflected means what? Changes their direction. Deflected in electric field. Okay, electric field. If you place electric field on either side of the discharge tube, then what happens? Instead of moving straight, they move towards the negative charge because they are the positive charge. So you know that they'll attract the negative charge. Opposite charges attract. So they'll be moving there. So they'll be moving towards the cathode, means negative charge. Hence, the meaning is what? They are deflecting. They are deflecting the electric field, and they can also deflect. Okay, they can also deflect in magnetic field. Magnetic field means what? If you arrange the magnetic field, one end north pole and one end south pole, then we observe that they are deflect even in the magnetic field also. Okay, so these are the main important properties, characteristics of the cathode anode rays. So anode rays travel in a straight line. Anode rays produces mechanical energy. Anode rays deflected by the both electric and magnetic fields. Okay, and here anode rays, the most important thing is that the charge of the anode. This is very important. Okay, the charge of the proton. So your anode rays are later named as what? Protons. I told you that protons. And here the charge of the proton is found to be, how much can you guess? What amount of charge present in the proton? Can you guess? Very good. How much it is? 1.602 into 10 to the power of minus 19 coulombs of positive charge. Why? Because atoms are neutral. In that electrons are there, protons are there. The amount of positive charge is equal to the amount of negative charge. And in the last class I discussed that electron carries 1.602 into 10 to the power of minus 19 coulombs negative charge. And then this positive charge should be equivalent to that one. So the charge on the proton is equal to the electron, that is 1.602 into 10 to the power of minus 19 coulombs. But electron carries a negative charge and this proton carries positive charge. That's the difference. Okay. So here, okay, the charge on electron, sorry, proton, charge on proton or cathode rays is equal to plus. You have to mention that plus. Okay, even if you don't mention, no problem. If there is no plus sign is there, the meaning is what? It is a positive only. For electron, you have to particularly mention that is minus because electron carries a negative charge, right? So this is about the charge on the proton, that is 1.602 into 10 to the power of minus 19 coulombs. And here the E/M ratio, like calculated in the J. Thomson. So here also the E/M ratio was calculated, but the E/M ratio, even what charge to mass ratio of the protons is different. Even charge is same, but E/M ratio, okay, that's called the specific charge. Okay, specific ratio, specific charge mass ratio is different from the electrons. Why? Because electrons mass is negligible, very small. Electrons mass is negligible, but the mass of mass of proton is equal to almost equal to the hydrogen atom. How much it is? Hydrogen atom. Okay, that means what? Almost 1840 times that of the electron. That of the electron. What we discussed in the last class, the electron mass is 1 by 1840th of the proton or hydrogen. We said the meaning is what? 1840 electrons if you constitute makes how much mass? That is equal to the mass of the proton. Okay, so proton mass is considered as the mass of hydrogen approximately equal to mass of hydrogen atom, and it is also called is equal to 1 AMU. 1 AMU. What is 1 AMU? 1 atomic mass unit. 1 AMU means what? 1 atomic mass unit is the mass of the proton. Okay, and if you want to mention in terms of grams, that was observed that 1.672. Okay, 1 point in terms of grams, 1.672 into 10 to the power of minus 24 grams, or 1.672 into 10 to the power of minus 27 kg. Okay, so 1 m is approximately equal to 1.672 into 10 to the power of minus 24 grams, or 1.672 into 10 to the power of minus 27 kg. So this is the mass of the proton. Clear, students? Any doubt here? So that's all about the characteristics of the anode rays. Any doubt? So once again, see here, anode rays travel in a straight line. They produce mechanical energy, and they are deflected by both electric and magnetic fields. And the charge on the proton is 1.602 into 10 to the power of minus 19 coulombs of positive, and the mass of the proton is equal to hydrogen, approximately hydrogen atom's mass, that is equal to 1 AMU, and 1 AMU means a proton mass is 1.672 into 10 to the power of minus 24 grams, or 1.672 into 10 to the power of minus 27 kgs, because 1 kg is equal to 1000 grams, right? So this becomes 24 to the power of 27. Okay, so that's all about the characteristics of the anode rays, right? Now here they discussed about the atomic model. What they discussed here? Atomic model. Okay, so the atomic model. So here, what is with the atomic model? Atomic model is nothing but the distribution. What is that? Distribution of charge and mass of in an atom is called the atomic model. Okay, so here atomic model means what? How the atom is present, and in that atom what are the particles are present, and these particles where they are present in an atom. Okay, so that distribution of the charge masses in an atom is called atomic model, right? So here the first atomic model was given by the proposed by the J.J. Thomson. Who proposed it? J.J. Thomson. Okay, so J.J. Thomson proposed first atomic model. Atomic model. So atomic model means what? The distribution of the charges and masses, okay, or particles in an atom is called atomic model. And the first atomic model was proposed by whom? J.J. Thomson. Okay, because he was the person who invented or who discovered the electrons first time. So he was the person to say that atoms can be divisible. Before the J.J. Thomson, what the people thought? Atoms are indivisible, they are unbreakable, we cannot break them, right? But here he was the person who proved that atoms are breakable, we can break the atoms, right? And when we break the atoms, from that as more smaller particles will be released, they are called electrons and so on. Okay, so when the J. Thomson discovered the electrons, he did not know about the protons. He did not know about the protons, how they are present. But he knew that the positive charge, is present in the atom, right? So based on that, he proposed one atomic model. So according to his atomic model, what he said is, atoms are like spherical in shape. How they are? Spherical in shape, means like ball. Here it's looking like circle, but imagine that they are spherical. Okay, They are spherical in shape. Atoms are spherical in shape. And this atom is fully distributed with a positive charge. Okay, it's fully distributed with a positive charge. Means what? The total atom is present with a positive charge. Okay, the total is distributed with what? Positive charge. Means total atom has a positive charge. According to J. Thomson, what is that? Atoms are spherical in shape. It is a positively charged sphere. It's better to tell like this. Atom is a positively charged sphere. Means what? The total atom consists of a positive charge. And he discovered the electrons. Then he said that the electrons will be embedded in it. Okay. So like this. Electrons, okay, are present in that. Electrons are distributed like this. Like this, electrons are present. Okay, so this is the J. Thomson's atomic model. So J. Thomson atomic model, what it states here? He states that what he explained about the atom? Atoms are positively charged spheres. Means what? Atoms are spherical in shape, and the total atom is distributed the positive charge, present the positive charge. Okay, and in that electrons will be embedded like this. Okay, now once you see that, just imagine that. Okay, so it is circular and total inside red color, and in that black color. Can you guess some fruit like this? Yes. Guess one fruit which looks like similar to that one. Come on, students. Just guess. Okay, a fruit which is spherical in shape. Right? Inside total red color mass will be there. And the red color mass seeds will be there. Come on, come on, come on, come on, come on. Good. What is that? Watermelon. Yes. So how the watermelon is? Watermelon is spherical in shape, right? It's a round. If you cut the watermelon, then what you can see? Inside total red color mass is there. Right? Red color mass is there. And when you open the red color mass, then what you can find? The black color seeds you can find. Yes? So, similar to this one. Okay? So, if you think atom is a watermelon, think atom is a watermelon. And that how the red color mass is there inside throughout the atom, through the watermelon. Similarly, the positive charge is present throughout the atom. And then how the seeds are present inside. Similarly, the electrons are present in the atom. Understood? So this is the atomic model proposed by the J. Thomson. So that's what J. Thomson model is also called as watermelon model of atom. Okay, which model? Watermelon model of atom, because he compared the structure of an atom with the watermelon, right? And one more time, if you observe the picture, how it looks like? It looks like, see how it looks like once you guess. Okay, it's looking like okay, it's looking like how? It's looking like a dry fruits cake. Yes, plum cake. Yes, plum cake, how it will be? The cake, plum cake, and inside all dry fruits will be there, right? So, similarly, here we can say that how the plum cake is there. Similarly, the atom is there and totally distributed with the positive charge. In that, how the dry fruits are present, like this, electrons are present. So, this is called, this is J. Thomson's atomic model. So, he was the first person to explain the structure of an atom. So, who is the first, which was the first atomic model? J. Thomson atomic model. What is also called as watermelon model or plum pudding model. Clear? Okay. So, with this topic is done, And here let's check whether you understood this topic or not. So I am going to ask the questions, so you give the answers. Okay. So I am going to ask the questions and give the answers. So if you have material, open the page number 141. Let's explore, right? Practice it. Anode rays were discovered by. Anode rays were discovered by who? What happened? See on the board. Did I write? I mentioned the name, but I didn't write the name of the scientist, I think so. Right? So that is Goldstein. That actual name only I forgot. Okay, he was the scientist Goldstein. Right? So Goldstein was the scientist who discovered the protons. Option is 1. Anode rays are negative, positive, neutral, all of these. Anode rays are what? Positive, red color, positively charged. So answer is 2. Anode rays travel in. How the anode rays travel? See on the board. Straight line. Okay? They travel in a straight line. Answer is 1. Next, anode rays deflected in. Where they deflected? They deflected in electric field. They deflected in magnetic field. So first option is electric field, second option is magnetic field, third option is both 1 and 2. So answer is both 1 and 2. J. Thomson model of an atom commonly known as. J. Thomson model commonly known as what? Watermelon, planetary, solar and Bohr. What is the answer? Watermelon. Just what I told you, no? It is similar to watermelon. Okay? So watermelon. So option is what? 1. Neutron possess. Neutron. Electron possess negative charge. Proton possess positive charge. And neutron possess no charge. So that's called neutral or no net charge. Right. Positive charge. Positive rays are positively charged particles. Positive rays are nothing but positively charged particles. So these are what? Positively charged particles. This red color one are what? Positively charged particles. Right. Which one of the following describes the neutron? Charge 1, no. 0 charge. 0 charge and 1 AMU. So the charge of neutron is 0 and approximately 1 AMU, 1 atomic mass unit. The specific charge for the cathode rays is constant. This is a last chapter question. Specific charge means what? E by M ratio. Okay. The specific charge. That's what? E by M ratio of electron. Is a constant. Okay. That's always same. The absolute charge of the proton. The absolute charge of the protons here 1.602 into 10 to the power of minus 19 coulombs of positive. So what the answer? Plus 1.602 plus 1.602 into 10 to the power of minus 19 coulombs. That is the first option. Right? Then over, that's all. Okay, some other questions. We have a time now. So some other questions also we discuss. The mass of the proton was calculated as being equal to the mass of atom. So which atom the mass of the proton is equal to? See here, the mass of the proton is equal to mass of the hydrogen atom. So option is what? 3. Right? Protons are denoted by the symbol protons, just P. Protons P and its mass is 1 and its charge is plus 1. Okay. So mass is 1 and its charge is plus 1. So the answer is 3. Mass of proton already we discussed 1.672 into 10 to the power of minus 24 grams, correct? 1.672 into 10 to the power of 27 kgs, this also correct. So see 1.672 into 10 to the power of minus 24 grams and 1.672 into 10 to the power of minus 27 kgs. So the option is both 1 and 2. Next, select the correct statement. Cathode rays have only charge but no mass. Actually, they have very less mass, but we don't consider the mass. Okay. Anode rays are deflected by electromagnetic fields. Yes, they are deflected. This second statement is perfectly correct. Canal rays are named as a beam of protons. Yes. Anode rays is also called as a canal rays. They are nothing but a beam of protons. Anode rays travels in straight line. Yes, anode rays travels in a straight line. Only the first point is a little contradiction because they said that the massless, no mass. They have a mass but very, very less. That is negligible mass. Okay. So remaining all are correct. Next, nitrogen plus helium gives us X plus 1, that is nothing but oxygen. So, option directly we can write here. So, that is oxygen. Which are the following characteristics of the anode rays? Which are the following are the characteristics of the anode rays? A, the E by M ratio positive depends on the nature of the gas. Yes. Second one, anode rays are deflected. Yes. Anode rays cause mechanical motion. Yes. Mechanical motion. Yes. Anode rays travels in a straight line. That also yes. And anode rays constitute positively charged particles. Yes, they are positively charged particles. So, all are correct here. So, option is 2. Thomson atomic model can explain only electrically neutrality. Yes. So, option is 2. The nature of anode depends on the nature of the gas which is present, that is nature of the gas, and of course nature of the electrode also, nature of the discharge tube also, right. So, option all the above. Which of the following pairs have the identical values of E by M? Proton and neutron? No, because neutron is no charge, proton is positive charge. Proton and deuterium? Deuterium means what? Hydrogen with the 1 and 2 mass number? No. Deuterium and alpha particle? Deuterium and alpha particle. Deuterium atomic number 2, mass number. Here there is a contradiction. E by M. E by M, charge to mass ratio. Alpha particle means what? The charge is plus 2 and mass is 4 units. Okay. And so here deuterium is what? Deuterium is hydrogen 2 plus 2, mass is also 2. No students, here this is wrong. Okay. This is wrong. Here no option, correct option is not there, leave it. Okay. Now come to the 10th one here. The fundamental particles present in the nucleus of an atom. In the nucleus means in the center of an atom, what are the particles present? Protons and neutrons are present in the nucleus. Electrons will be revolving around the nucleus, that we see in the next class. Okay. Thomson model is also called as, Thomson model is also called as watermelon. And the increasing order of the specific charge of electron, proton, alpha particle and neutron. So here, first option, electron is least, then proton, then neutron, then alpha particles. The charge to mass ratio on alpha particle is approximately charge to mass ratio of proton is twice because its mass is 4, right? That's all. And the positive charge of the proton is, the charge of the proton is this one, 1.602 into 10 to the power of minus 19 coulombs. Okay students, so with this we do, and my task time that you do. So hope that topic understood. And a very simple topic, very easy topic. Once again, read this topic perfectly and try to answer these topics. Okay. So with this, we stop the class. Hope you understood. And till next class, take care. Bye.